All right, we're heading to the bottom of the world today, to the coldest, driest, and highest continent on Earth, because something is happening there. Something that's heating up at a really alarming rate. We are talking about Antarctica, where a series of changes are unfolding that honestly could have massive consequences for every single one of us.
Catastrophic consequences for generations to come. I mean, wow, those aren't my words. They come from Dr. Nearly Abram, one of the top scientists studying the continent. That warning right there just immediately sets the stage for what is at stake. This isn't some abstract problem for the distant future. It's a real threat, and it's on a very real timeline. So here's the bottom line. That gigantic ice sheet we all picture as this permanent, stable fixture of our planet, well, it's waking up, and it's not happening slowly or gradually. The changes scientists are seeing are abrupt, they're sudden, and they're happening way faster than even the recent predictions thought possible. To put a number on this threat, think about this. 3 meters. That's about 10 feet. That is the potential global sea level rise we're facing from the collapse of just one part of Antarctica. And it's a collapse that a lot of researchers now think might already be unstoppable. But to really get a handle on the risk, we have to understand that Antarctica isn't just one big, solid block of ice. It's really a continent of 2 halves, each with a totally different story. And one of those halves has a major weak spot. And this slide really shows you the critical difference. So over on the left, you've got the East Antarctic ice sheet. It's colossal, it sits high up on solid ground, and it's pretty stable. I mean, it holds enough ice to raise sea levels by almost 200 feet. But then you look to the right, at West Antarctica. It's smaller, sure, but here's the kicker. Its base is resting on bedrock that's below sea level. And that vulnerability, well, that changes everything. This concept right here is the absolute key to understanding the whole problem. A marine-based ice sheet is literally in direct contact with the ocean. So, as our oceans get warmer, that warm water can sneak right underneath the ice and melt it from the bottom up. It's kind of like taking a block of ice out of the freezer and putting it in a bowl of warm water instead of on a cold table. And this is where the danger really gets amplified. The ground under the ice in West Antarctica doesn't just sit below sea level. It actually slopes downward the deeper you go. This is called a retrograde slope. What that means is as the ice starts to melt and retreat, it exposes an even thicker, taller face of ice to that warm ocean. And that in turn just makes the melting and the retreating happen even faster. It creates this vicious feedback loop. So if West Antarctica is the continent's weak spot, where exactly is the bullseye? Let's zoom in on the one single glacier that has scientists all over the world just holding their breath. Okay, take a look at this. This isn't a simulation or a forecast. This is real data from satellites showing what is happening right now. The colors are basically a speed map for ice loss. See all those bright red and orange zones? That is exactly where the ice is moving faster and the surface is dropping. And as you can see, all the alarm bells are flashing right over one place, the Thwaites Glacier. The nickname really says it all. People call it the Doomsday Glacier because it's so incredibly important. It basically acts like a cork in a bottle, holding back a huge portion of the entire West Antarctic ice sheet. If Thwaites goes, its collapse could pull the plug on the glaciers all around it, triggering a much, much wider collapse. It is the linchpin. So, we've figured out the what and the where. Now for the really crucial part, the how. What are the actual physical things happening that could drive a collapse like this? Let's break down the science. This drawing really shows the glacier as a kind of battlefield. You can see the ice flowing from the land on the left out to the floating ice shelf on the right. And just notice how it's getting attacked from everywhere. From the warm air above, yeah, but most importantly, by those warm ocean currents that are sneaking in underneath. And here's the main culprit. It's a layer of ocean water that's pretty warm, relatively speaking, and salty. It's called circumpolar deep water. And because of changes in wind patterns, this warmer water is getting pushed up from the deep ocean and aimed directly at the base of these glaciers, where it just eats away at the ice day in and day out. And this visualizes that runaway cycle we were talking about, something called marine ice sheet instability. Let's just walk through it. First, warm ocean melts the base. That causes the grounding line, where the ice actually touches the rock, to move back. Because of that downward slope, it retreats into deeper water, which exposes a much thicker wall of ice. That new, taller cliff then starts to flow faster just under its own weight, and that pulls even more ice from the interior out into the warm ocean. And the whole cycle just spins faster and faster. But that's not the only thing going on. As the air gets warmer, we're seeing more melting on the surface of the ice. When that meltwater collects in big cracks on the ice shelf, its sheer weight can drive those cracks deeper and deeper, acting just like a wedge. This process is called hydrofracture, and it has the power to completely shatter the floating ice shelf that's holding the glacier back.
And if that ice shelf does shatter, well, then you've exposed this massive vertical cliff of ice to the open ocean. Scientists have a theory that once this cliff gets taller than about 100 meters, that's over 300 feet, it just can't support its own weight anymore. It becomes unstable and can start to just crumble in a process called marine ice cliff instability.
So the really critical thing to get here is that you have this triple threat. You've got melting from below, you have fracturing from above, and then you have the potential for this rapid structural collapse at the front. You put all those together and you have a recipe for losing a massive amount of ice terrifyingly fast. We're talking decades or centuries, which on a geological scale is the blink of an eye.
Okay, so now let's zoom back out, because the fate of one glacier, even a giant one like Thwaites, doesn't happen in a bubble. Its collapse could be the first domino to fall in a much, much bigger global cascade. A tipping point. It's a threshold where just a tiny little push can shove an entire system into a completely new state, and often a state you can't come back from. And a lot of scientists now think that the collapse of the West Antarctic ice sheet could be one of those huge tipping points for the entire planet's climate.
See, the danger is that all of Earth's climate systems are interconnected. You trigger one tipping point, like a major ice sheet collapsing, and that can add stress to all the others. It could speed up the thawing of permafrost, which releases more greenhouse gases, or mess with the ocean currents that control our weather. It could create a domino effect that ripples across the entire planet.
These simulations really visualize what the science is telling us. Just look at the models as you go from left to right, each one showing more and more warming. At 2 or 3 degrees of warming, the ice sheet is mostly okay. But look what happens at 4 and 5 degrees. A line is crossed, a threshold is passed, and the ice sheet just enters this state of rapid, irreversible collapse. It's not a slow, gradual melt anymore. It's like a switch just gets flipped. The ultimate risk of setting off this cascade is a future that scientists call hothouse Earth. That's a state where the planet's own feedback loops start to drive the warming themselves, locking us into a much hotter, much more hostile world for thousands of years. It's a true point of no return for the stable climate that has allowed all of human civilization to thrive. The science is getting clearer practically every day. The warnings coming from places like Thwaites Glacier, they're not whispers anymore, they're roars. Scientists have mapped out the danger. They've identified the line in the sand. And that leaves us with one final urgent question that goes way beyond the science and right into all of our lives. We know where the cliff's edge is. The only question is, what are we going to do before we cross it?